Hello dear learners, I'm Zinnah. I'm a chemistry teacher. My mission is to make chemistry simple for the learners. Today I'm with electrochemical cell. Look at the word electrochemical cells. Cell means it's a device, and two other things are also there, electro and chemical. Altogether, electrochemical cell. And if you get any device with electro means electricity and chemical means chemical reactions, these two things together, then the cell is called electrochemical cell. Electrochemical cells have types and we're going to look into them. Electrochemical cell. An electrochemical cell is a device which either produces electricity by chemical reactions or use electricity to make chemical reactions to take place. Questions. What is called electrochemical cell? How many types of electrochemical cells are there? Types of electrochemical cells. We get two types of electrochemical cells: electrolytic cell and galvanic cell. Electrolytic cells. The electrochemical cells which use electricity to make chemical reactions to take place are called electrolytic cells. Any electrolysis is an electrolytic cell. Galvanic cell. The electrochemical cells which produce electricity by chemical reactions are called galvanic cells or voltaic cell. Question. What are the differences between electrolytic cells and galvanic cells? Facts of galvanic cells. With an experiment, we can develop the facts of galvanic cell. The experiment is a small piece of zinc metal is dropped in aqueous copper 2 sulfate solution. And after the reactions, you will get two changes. One, blue solution gradually turns colorless, and the gray metal turns brown. Questions. Which of the metals, copper or zinc, is more reactive? And how do you understand this from this experiment? Why does the color change in this experiment? What type of reactions takes place in the experiment? For the answer of the question, we analyze the experiment. As zinc is more reactive than copper, it displaces copper from copper 2 sulfate solution. The copper 2 sulfate solution is blue, but the new solution formed is zinc sulfate, which is colorless. The reaction is a redox reaction, both oxidation and reduction together. We show with the equation zinc here, the gray solid, and blue copper sulfate solution. The reaction produces copper metal and zinc sulfate. Now we're going to write the equation again with charges of the ions. Copper sulfate is an ionic compound, consists of copper ion and sulfate ion. And zinc sulfate is another ionic compound, consists of zinc ion and sulfate ion. If you look at the equation carefully, you get zinc and copper are on both sides, but they are not same. On left side you get zinc metal, on right side you get zinc ion. On left side you get copper ion, on right side you get copper metal, which means they got change in the reaction. But one of the ions there in this equation doesn't get any change. Certainly this is sulfate. This sulfate doesn't change in the equation. We call this sulfate ion as spectator ion here. And we're going to write the equation again without sulfate. So we get zinc plus copper ion, get copper plus zinc ion. This is called an ionic equation, and this is also a redox reaction which consists of both oxidation and reduction. Look, zinc metal to zinc ion. This certainly has been by losing electrons. Here you see zinc losing 2 electrons to form zinc ion, and these 2 electrons are gained by copper 2 ions to form copper metal. The first one is oxidation because zinc losing electron. The second one is reduction because copper ion gaining those electrons. And these two equations together, we write the overall equation, zinc plus copper ion giving copper plus zinc ion is a redox. This reaction between zinc and copper ion is very important because this is a redox reaction, and we can use this reaction to generate electricity, because here get zinc loses electrons and copper ions gain electrons, and if you just place them separately and connecting them with an electric cable, they are automatically producing electricity, and electrons will move from zinc to the copper ions. And let's see how we can make this. The first person, Daniel, who devised this experiment to make electricity. So this galvanic cell is also known as Daniel cell. And to make a Daniel cell, you just need to have 2 beakers. And to one of the beaker, add aqueous zinc sulfate solution. This contains zinc ion and sulfate ion. And to the other beaker, add aqueous copper 2 sulfate solution, which will contain copper ion and sulfate ion. Now put a zinc bar to the zinc sulfate solution and a copper bar to the copper sulfate solution. Now if you connect this bar with an electric wire containing a bulb, you will get the bulb will light. How come? Here's that zinc bar, which is anode here, an oxidation reaction takes place. Zinc loses electron to form zinc ion, and these 2 electrons move through the external wire to the copper electrode. And in the copper sulfate solutions, there are copper ions which gain electrons to form copper metal. For these reactions, you will get few changes in the solutions. One, as zinc dissolves, zinc loses electrons to form zinc ion and move to the solutions. So gradually, zinc will decay and get thinner. On the other hand, copper bar will be thicker because the copper ion from the solution will gain electron to form copper metal and deposit at the copper bar. Another thing will happen there, which is in the zinc sulfate solution, amount of zinc ion will increase because zinc ions are coming from zinc metal. So in this solution, you will have more zinc ion than sulfate ion. And in the copper sulfate solution, you will have more sulfate ion than copper ion. This is because copper ion from the solution gain electron and deposit at copper electrode, leaving the sulfate ion behind. So gradually, the zinc sulfate solution will be positive and copper sulfate solution will be negative. This imbalance of the charges will slow down the process, and the cell will be faint away gradually. To solve this problem, you can use a salt bridge. The salt bridge, a bridge connecting these 2 solutions together. The salt bridge mainly contain a highly soluble salt. Sodium sulfate is an example. How they solve problems? When the zinc sulfate solution is highly positive, then the sulfate ion from the salt bridge come into the zinc sulfate solution, balancing the charges in the zinc sulfate solution. And sodium ion from salt bridge get into the copper sulfate solution. And this is how the charges are balanced and the battery lasts longer period of time until you have zinc metal, zinc bar, and copper ion in the copper sulfate solution. And if you replace the bulb with a voltmeter, and you will get the voltage potential difference between the electrodes.
The Daniell cell uses zinc metal, copper metal, and their ion. Not only zinc and copper, using many other metals and many other things, we can make galvanic cells. And we're going to have some examples here.
Lead battery is also a galvanic cell. This is normally a car battery. Look inside the car battery. Here are two plates, two electrodes. One is made of lead metal and another is lead dioxide. And in the solution you have dilute sulfuric acid. The reactions at anode, lead metal loses electrons to form lead ion, and this is an oxidation. At cathode, lead dioxide gains electrons with sulfuric acid and form lead ions. So electrons flow from anode to the cathode. Dry cell is another example of galvanic cell. This is a dry cell, and look inside the dry cell. At the middle of the dry cell you have a graphite rod, which is cathode here, positive electrode. And the container is a zinc case. Itself works as anode and negative electrode. And a paste of manganese dioxide, ammonium chloride, and carbon powder is placed in the container. Look at the reactions at anode. The zinc is anode, which itself oxidizes to give electrons and form zinc ion. At the cathode, the reaction is ammonium and manganese dioxide together gains electrons to form ammonia gas, dimanganese trioxide, and water, and get the overall equation: zinc plus ammonium ion from ammonium chloride, manganese dioxide giving you zinc ion, ammonia gas, dimanganese trioxide, and water. As ammonia gas and water produce in this reaction, the battery gets damped and with a bad smell of ammonia gas. And the battery lasts as long as you have zinc, metal, and manganese dioxide, ammonium ion in the paste.
And these were all about galvanic cell. And I think with the discussion, clarification, and PowerPoint animation, your concept of galvanic cell has been very clear and you have enjoyed the video. Thank you very much.